Capacitors are used in virtually every area of electronics, and they perform a variety of different tasks, like coupling between stages of an audio system. Let me show you what happens inside a radio while tuning it. The component of the circuit where you can see its moving parts is a capacitor. So capacitors have a major role in making you hear your favorite radio station. It is also there in a camera flash circuit, in timers, for controlling the charging and discharging, smoothing a power supply, etc.
Dear students, ਤੁਹਾਡਾ ਸਾਰਿਆਂ ਦਾ ਇਲੈਕਟ੍ਰੋਸਟੈਟਿਕਸ ਦੀ ਇੱਕ ਹੋਰ ਇੰਟਰਸਟਿੰਗ ਅਤੇ ਯੂਜ਼ਫੁਲ ਕਲਾਸ ਵਿੱਚ ਸਵਾਗਤ ਹੈ। ਇਸ ਚੈਪਟਰ ਵਿੱਚੋਂ ਹੁਣ ਤੱਕ ਅਸੀਂ ਇਲੈਕਟ੍ਰੋਸਟੈਟਿਕ ਪੋਟੈਂਸ਼ੀਅਲ ਅਤੇ ਇਕੁਇਪੋਟੈਂਸ਼ੀਅਲ ਸਰਫੇਸਿਸ ਬਾਰੇ ਚੰਗੀ ਤਰ੍ਹਾਂ ਜਾਣ ਚੁੱਕੇ ਹਾਂ। ਸਾਨੂੰ ਇਲੈਕਟ੍ਰਿਕ ਕੰਡਕਟਰਸ, ਇਨਸੂਲੇਟਰਸ ਅਤੇ ਡਾਇਲੈਕਟ੍ਰਿਕਸ ਬਾਰੇ ਵੀ ਜਾਣਕਾਰੀ ਹੈ। ਅੱਜ ਦੀ ਇਸ ਕਲਾਸ ਵਿੱਚ ਅਸੀਂ ਫਿਜ਼ਿਕਸ ਦੇ ਇੱਕ ਹੋਰ ਪੱਖ ਬਾਰੇ ਆਪਣਾ ਗਿਆਨ ਵਧਾਵਾਂਗੇ। ਅੱਜ ਅਸੀਂ ਕੈਪੈਸਿਟਰ ਨਾਂ ਦੀ ਇੱਕ ਡਿਵਾਈਸ ਬਾਰੇ ਪੜ੍ਹਨ ਜਾ ਰਹੇ ਹਾਂ। ਸਿਲਸਿਲੇਵਾਰ ਸ਼ੁਰੂ ਕਰਨ ਤੋਂ ਪਹਿਲਾਂ ਮੈਂ ਤੁਹਾਡੇ ਨਾਲ ਅੱਜ ਦੇ ਲਰਨਿੰਗ ਆਬਜੈਕਟਿਵਸ ਸਾਂਝੇ ਕਰਨਾ ਚਾਹਾਂਗੀ।
Describe a capacitor and capacitance. Write an expression for the capacitance of a capacitor. Discuss the capacity of an isolated spherical conductor. Describe the principle of capacitors. Solve numerical problems related to capacitors.
ਆਓ ਕੁਝ ਇਹੋ ਜਿਹੀਆਂ ਬੁਨਿਆਦੀ ਗੱਲਾਂ ਨਾਲ ਸ਼ੁਰੂ ਕਰੀਏ ਜਿਨ੍ਹਾਂ ਬਾਰੇ ਅਸੀਂ ਪਹਿਲਾਂ ਵੀ ਜਾਣਦੇ ਹਾਂ। ਇਹਨਾਂ ਬੇਸਿਕ ਟਰਮਸ ਦੀਆਂ ਡੈਫੀਨੇਸ਼ਨਸ ਅਤੇ ਹੋਰ ਨੌਲੇਜ ਅੱਜ ਦੇ ਪਾਠ ਨੂੰ ਸਮਝਣ ਵਿੱਚ ਮਦਦ ਕਰਨਗੀਆਂ। ਇਨਸੂਲੇਟਰਸ ਅਤੇ ਕੰਡਕਟਰਸ ਕੀ ਹੁੰਦੇ ਹਨ ਇਹ ਤਾਂ ਤੁਸੀਂ ਜਾਣਦੇ ਹੀ ਹੋ। Can you recall the definition of insulators? We know that the materials which do not have too many free electrons in them are unable to conduct electricity and are termed as insulators. Let us recall some important aspects of conductors again. The atoms which have their valence shells filled less than half are found to be good conductors. Conductors contain mobile charge carriers. Do you know what the charge carriers in metals are? Well, in metals, the electrons behave as the charge carriers. These electrons are free to move within the metal but not free to leave the metal. The free electrons forms a sort of gas as they move and collide with each other and with the ions. The positive ions made up of nuclei remain fixed at their positions. In electrolytic conductors, that is liquids, the charge carriers are both positive and negative ions. Can you define ions? The positive ions are atoms or groups of atoms that are deficient of electrons. The negative ions can be free electrons or atoms and groups of atoms with an excess of electrons. Also, both types of charge carriers in liquids are mobile. They move in a random manner. The average velocity of free ions in a conductor is 0. But when an external electric field is applied across the two ends of a metal, the free electrons are forced. They get accelerated due to the applied field. As the strength of the applied field is increased, more free electrons move across the metal. Let me show you the movement of electrons through conductors.
Here is an open circuit where no potential difference is applied across the conductor. The orange balls are representing the atoms and the blue balls are representing the electrons in their valence shells. Please note that there is no electron movement in the absence of the potential difference. Then a potential difference is applied. The electrons start moving in random directions from one atom to another as shown by the emitter. When the potential difference applied is increased, more electrons are knocked from their respective atoms and constitute a higher current.
ਹੁਣ ਇਹ ਪਤਾ ਲਗਾਉਣ ਦੀ ਕੋਸ਼ਿਸ਼ ਕਰਦੇ ਹਾਂ ਕਿ ਕਿਸੇ ਇਲੈਕਟ੍ਰੋਸਟੈਟਿਕ ਫੀਲਡ ਵਿੱਚ ਰੱਖੇ ਕੰਡਕਟਰ ਦਾ ਬਿਹੇਵੀਅਰ ਕੀ ਹੋਵੇਗਾ। ਕੰਡਕਟਰ ਵਿਚਲੇ ਫ੍ਰੀ ਇਲੈਕਟ੍ਰॉन्स ਫੀਲਡ ਦੇ ਪੋਜ਼ਿਟਿਵ ਟਰਮੀਨਲ ਵੱਲ ਮੂਵ ਕਰ ਜਾਂਦੇ ਹਨ ਅਤੇ ਇਸ ਤਰ੍ਹਾਂ ਇਲੈਕਟ੍ਰॉन्स ਆਪਣੇ ਆਪ ਨੂੰ ਰੀਅਰੇਂਜ ਕਰ ਲੈਂਦੇ ਹਨ। ਅਖੀਰ ਕੰਡਕਟਰ ਦੇ ਸਰਫੇਸ ਤੇ ਚਾਰजेस ਦਾ ਰੀਡਿਸਟ੍ਰੀਬਿਊਸ਼ਨ ਅਪਲਾਈਡ ਫੀਲਡ ਨੂੰ ਕੈਂਸਲ ਕਰ ਦਿੰਦਾ ਹੈ। ਕੰਡਕਟਰ ਦੇ ਅੰਦਰ ਨੈਟ ਫੀਲਡ 0 ਹੋ ਜਾਂਦੀ ਹੈ। ਚਲੋ ਤੁਹਾਨੂੰ ਇਹ ਸਥਿਤੀ ਦਿਖਾਈਏ।
Note carefully the charges are developed on the conductor placed inside an electrostatic field. See that the electrons in the conductor move towards the positive of the electrostatic field and vice versa. A rearrangement of the electrons take place in such a manner that charges appear on the surface of the conductor and field is set up, which cancels the applied field. This makes the net field inside the conductor as 0. Remember, if there was a non-zero field inside the conductor, there would have been a flow of current inside the conductor. Then the electric field at the surface of the conductor or just outside it cannot have a tangential component. Had it been so, there would be a flow of surface current. Therefore, when the conductor is placed in the electrostatic field, the electric field lines will enter or leave the conductor at right angles to the surface of the conductor.
ਆਸ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਇਹ ਸਮਝ ਆ ਗਿਆ ਹੋਵੇਗਾ ਕਿ ਕਿਸੇ ਵੀ ਕੰਡਕਟਰ ਦੇ ਇੰਟੀਰੀਅਰ ਵਿੱਚ ਨੈਟ ਇਲੈਕਟ੍ਰਿਕ ਫੀਲਡ 0 ਹੋਵੇਗੀ ਅਤੇ ਇਸ ਦੇ ਅੰਦਰ ਕਿਤੇ ਵੀ ਕੋਈ ਨੈਟ ਚਾਰਜ ਨਹੀਂ ਹੋ ਸਕਦਾ। ਇਸ ਸਥਿਤੀ ਨੂੰ ਗੌਸ ਥਿਓਰਮ ਦੀ ਸਹਾਇਤਾ ਨਾਲ ਪ੍ਰੂਵ ਕਰਨ ਦੀ ਕੋਸ਼ਿਸ਼ ਕਰਦੇ ਹਾਂ। Consider a Gaussian surface just inside the surface of the conductor. Since there is no electric field inside the conductor, the electric flux inside the conductor must be 0. According to Gauss theorem, there is no charge in the interior of the conductor. Therefore, when a conductor is placed inside an electric field, the conditions that apply to it are: both the electric field and the charge are 0 inside the conductor. The charges stay only on the surface of the conductor. Outside the surface of the conductor, the electric field is perpendicular to its surface. The whole body is at a constant potential. This is so because the electric field inside the conductor can be 0 only when the potential inside the conductor is constant. We are now ready to understand a capacitor and its capacitance. Let me first tell you what is a capacitor. A capacitor is an electrical or electronic device that can store energy in the electric field between a pair of conductors. These conductors are called as plates. The two plates are separated by an insulator. They are given equal and opposite charges. The process of storing energy in the capacitor is known as charging. Let me now give you the principle of a capacitor. Under normal circumstances, a conductor can store small charges and so has a small capacitance. In order to store a bigger charge, more than one conductors are arranged to form a capacitor. Thus, a capacitor has a large capacitance to store large charge in a small space. The principle behind the phenomenon can be understood by considering a metal plate. Let it be named A. ਮੰਨ ਲਓ ਇਸ ਪਲੇਟ ਨੂੰ ਉਦੋਂ ਤੱਕ ਪੋਜ਼ਿਟਿਵ ਚਾਰਜ ਦਿੱਤਾ ਜਾਵੇ ਜਦੋਂ ਤੱਕ ਕਿ ਇਸ ਦਾ ਪੋਟੈਂਸ਼ੀਅਲ ਮੈਕਸਿਮਮ ਹੋ ਜਾਵੇ। ਹੁਣ ਜੇ ਇਸ ਨੂੰ ਅਨਡਿਸਟਰਬਡ ਛੱਡ ਦਿੱਤਾ ਜਾਵੇ ਤਾਂ ਇਸ ਦਾ ਚਾਰਜ ਸਰਾਊਂਡਿੰਗਸ ਨੂੰ ਲੀਕ ਹੋ ਜਾਂਦਾ ਹੈ। ਮੰਨ ਲਓ ਇਸ ਪਲੇਟ ਦੇ ਨੇੜੇ ਇੱਕ ਹੋਰ ਮੈਟਲ ਪਲੇਟ B ਰੱਖ ਦਿੱਤੀ ਜਾਂਦੀ ਹੈ। ਇਸ ਦੇ ਪਲੇਟ A ਵੱਲ ਦੇ ਫੇਸ ਤੇ ਨੈਗੇਟਿਵ ਚਾਰਜ ਇੰਡਿਊਸ ਹੋ ਜਾਵੇਗਾ। स्पष्ट है कि दूजे फेस ते पॉजिटिव चार्ज होवेगा। प्लेट B ते इंड्यूस्ड नेगेटिव चार्ज होने कारण प्लेट A दा पोटेंशियल लो हो जाता है। हाँ, दूजे फेस ते इंड्यूस्ड पॉजिटिव चार्ज कारण ये थोड़ा जिहा राइज भी हो जाता है। हुण मेटल प्लेट दी थिकनेस ता फाइनाइट है अते पॉजिटिव चार्ज नेगेटिव चार्ज दी बनस्बत थोड़ा जिहा ज्यादा दूर है। इस तरह ओवरऑल प्लेट A ਦੇ ਪੋਟੈਂਸ਼ੀਅਲ ਵਿੱਚ ਬਹੁਤ ਥੋੜਾ ਜਿਹਾ ਡਿਕਰੀਜ਼ ਹੁੰਦਾ ਹੈ। ਪਲੇਟ A ਦਾ ਪੋਟੈਂਸ਼ੀਅਲ ਮੁੜ ਕੇ ਉਨਾ ਹੀ ਕਰਨ ਲਈ ਇਸ ਨੂੰ ਥੋੜਾ ਚਾਰਜ ਹੋਰ ਦੇਣਾ ਪਵੇਗਾ। ਇਸ ਤਰ੍ਹਾਂ ਇੱਕ ਅਨਚਾਰਜ ਕੰਡਕਟਰ ਨੇੜੇ ਰੱਖਣ ਨਾਲ ਕੰਡਕਟਰ ਦੀ ਕੈਪੈਸਿਟੈਂਸ ਥੋੜੀ ਵੱਧ ਜਾਂਦੀ ਹੈ। ਹੁਣ ਜੇ ਪਲੇਟ B ਨੂੰ ਅਰਥ ਕਰ ਦਿੱਤਾ ਜਾਵੇ ਤਾਂ ਇੰਡਿਊਸਡ ਪੋਜ਼ਿਟਿਵ ਚਾਰਜ अर्थ वल फ्लो करेगा क्योंकि वो प्लेट A दे पॉजिटिव चार्ज द्वारा रिपेल किया जाएगा। जे प्लेट A दा पोटेंशियल मुड़ के पहला जिन्ना करना होवे तां हुण इस नू ह्यूज अमाउंट ऑफ चार्ज प्रोवाइड करना होवेगा। इस तरह अर्थ कंडक्टर नेड़े रखण नाल कंडक्टर दी कैपेसिटेंस बहुत ज्यादा वध जाती है। This is the basis or the principle of a capacitor. This arrangement of two metal conductors, when one conductor is connected to the earth and the other has an ability to store a large amount of charge on it, is called a capacitor. When a conductor is given some electric charge, it is raised to some potential. More charge means more potential. The electric field in the region between the charge plates is proportional to the charge on the plates. It is equivalent to say that if the charge on the capacitor is doubled, the electric field is also doubled at every point. If a charge Q is given to the conductor so that its potential increases to an amount V, then it is found that Q is proportional to V or Q is equal to CV, where C is the constant of proportionality and is known as capacitance of the conductor. From the equation Q is equal to CV, we can write C is equal to Q upon V. Further, if V is equal to 1 volt, then the capacitance of the conductor is equal to its charge. That is, if V is equal to 1 volt, then C is equal to Q. Therefore, by definition, the capacitance of a conductor is the ratio of the electric charge onto its electric potential due to that charge. Numerically, the capacitance of a conductor may be defined as the electric charge required to raise its electric potential through one unit. In SI system of units, the unit of capacitance is farad, denoted by capital F. A capacitor is said to have a capacitance of 1 farad if 1 coulomb of charge raises its electric potential through 1 volt. Mathematically, 1 farad is equal to 1 coulomb upon 1 volt or 1 coulomb per volt. It can also be written as 1 CV raised to the power minus 1. ਤਕਰੀਬਨ ਸਾਰੀਆਂ ਪ੍ਰੈਕਟੀਕਲ ਸਿਚੁਏਸ਼ਨਸ ਲਈ ਕਿਸੇ ਕੈਪੈਸਿਟਰ ਦੀ ਕੈਪੈਸਿਟੈਂਸ ਐਕਸਪ੍ਰੈਸ ਕਰਨ ਲਈ ਇੱਕ ਫੈਰਡ ਬਹੁਤ ਵੱਡੀ ਯੂਨਿਟ ਹੈ। ਆਮ ਤੌਰ ਤੇ ਫੈਰਡ ਦੇ ਸਮਾਲਰ ਮਲਟੀਪਲਸ ਵਰਤੋਂ ਵਿੱਚ ਆਉਂਦੇ ਹਨ। The most commonly used sub-multiples of a farad are a microfarad, which is equal to 10 raised to the power minus 6 farad, and a picofarad, which is equal to 10 raised to the power minus 12 farad. An important question that must have occurred to you by now is that where are these capacitors used? Let me satisfy this question. Actually, capacitors are used in virtually every area of electronics and they perform a variety of different tasks. Some capacitors are used for coupling, others for decoupling, while others may be used in filters and some may be used for power supply smoothing. There are many different types of capacitors ranging from ceramic capacitors to electrolytic capacitors and silver mica capacitors to various forms of plastic or polyester capacitors. Capacitors ਦੀ ਹਰ ਕਿਸਮ ਨਾਲ ਉਹਨਾਂ ਦੀਆਂ ਐਡਵਾਂਟੇजेस ਅਤੇ ਡਿਸਐਡਵਾਂਟੇजेस ਜੁੜੀਆਂ ਹੋਈਆਂ ਹਨ। ਇਸ ਕਰਕੇ ਇਹਨਾਂ ਦੇ ਯੂਜ਼ਸ ਇੱਕ ਦੂਜੇ ਤੋਂ ਡਿਫਰੈਂਟ ਹੋ ਸਕਦੇ ਹਨ। ਕੁਝ ਦਾ ਪ੍ਰਯੋਗ ਹਾਈ ਫ੍ਰੀਕੁਐਂਸੀ ਸਿਚੁਏਸ਼ਨਸ ਲਈ ਜ਼ਿਆਦਾ ਚੰਗਾ ਮੰਨਿਆ ਜਾਂਦਾ ਹੈ ਤਾਂ ਕੁਝ ਦਾ ਲੋ ਫ੍ਰੀਕੁਐਂਸੀ ਐਪਲੀਕੇਸ਼ਨਸ ਲਈ। Indeed, it is necessary to have the right capacitor at its right place for the concerned circuit to work properly. Choosing the right capacitor used for the right capacitor is all part of the designing process for a circuit. Using the wrong type of capacitor can easily mean that a circuit will not work at all or is going to work with a very little efficiency. Let us now try a hand on simple numerical problems based on the formula of capacitance. Look at these numerical problems and try to solve them. A capacitor of 4 microfarad is connected to a 400 volt supply. What is the charge on its plates? The solution is C is equal to 4 into 10 raised to the power minus 6 farad. V is equal to 400 volts while Q is to be calculated. The formula used is C equal to Q upon V or Q is equal to C into V. Substituting the values of C and V, we get Q equal to 4 into 10 raised to the power minus 6 into 400, which on calculating comes out to be 1.6 into 10 raised to the power minus 3 coulombs. Consider one more problem. What is the capacitance of a capacitor if it is connected to a 100 volt supply and the charge on its plates is 2 into 10 raised to the power minus 9 coulombs? For the solution, we have to find the capacitance if V is equal to 100 volts and Q is 2 into 10 raised to the power minus 9 coulombs. The formula used is C equal to Q upon V. Putting the values of Q and V, C comes out to be 2 into 10 raised to the power minus 9 upon 100, which is equal to 2 into 10 raised to the power minus 11 equal to 20 into 10 raised to the power minus 12 farad or 20 picofarads. We will now discuss about the capacitance of a spherical isolated conductor. Well, this means a spherical conductor which is isolated from other surroundings. Even this will have a capacity. How? and how much? Let us study that. Look at this diagram. Let there be an isolated spherical conductor with center O and radius r. This will make the situation more clear. Let a charge plus q be given to the sphere. You know this charge spreads uniformly over the outer surface of the sphere, whether the sphere be hollow or solid. Thus, the potential at every point on the surface of the sphere remains equal. Also, the sphere behaves as if the entire charge on it were concentrated at its center. Hence, the potential at any point on the sphere in free space is given by V equal to Q upon 4 pi epsilon naught R. We already know that C is equal to Q by V. On substituting the value of V, the value of C can be written as Q 4 pi epsilon naught into R upon Q, or C equal to 4 pi epsilon naught into R. Here, of course, C is in farads and R in meters. From the relation C equal to 4 pi epsilon naught into R, it is clear that C is proportional to R. This means larger the radius of the sphere, greater is the capacitance of the sphere. Let me give you an interesting fact about this relationship. You know that a capacitor is made of two conductors, while we have calculated the capacity of a single spherical conductor, assuming the second conductor to be at infinity. Being aware of this situation, can we calculate the capacity of our Earth? Come, let's do so. Our Earth is a conducting sphere of an average radius of 6,400 kilometers, or 6.4 into 10 raised to the power 6 meters. We know C is equal to 4 pi epsilon naught into R. Substituting the values of 4 pi epsilon naught and R, we get C equal to 1 upon 9 into 10 raised to the power 9 into 6.4 into 10 raised to the power 6. This means C is equal to 0.711 into 10 raised to the power minus 3 farad, or C is equal to 711 microfarads. Let me put your brains to some more and interesting task. Can you tell me how many picofarads are there in a microfarad? Take a while to think. If your answer is 10 raised to the power 6 picofarads in a microfarad, then you are correct. Now, let me tell you something more about capacitors. ਤੁਸੀਂ ਇਹ ਜਾਣਦੇ ਹੋ ਕਿ ਕੈਪੈਸਿਟਰ ਇਲੈਕਟ੍ਰਿਕ ਚਾਰਜ ਸਟੋਰ ਕਰਨ ਵਾਲੀ ਇੱਕ ਡਿਵਾਈਸ ਹੈ। ਇੱਕ ਛੋਟੇ ਜਿਹੇ ਕੰਡਕਟਰ ਵਿੱਚ ਚਾਰਜ ਦਾ ਥੋੜਾ ਜਿਹਾ ਅਮਾਉਂਟ ਸਟੋਰ ਹੋ ਸਕਦਾ ਹੈ। ਇਸ ਕਰਕੇ ਇਸ ਦੀ ਕੈਪੈਸਿਟੈਂਸ ਥੋੜੀ ਹੁੰਦੀ ਹੈ। ਜ਼ਿਆਦਾ ਚਾਰਜ ਸਟੋਰ ਕਰਨ ਲਈ ਦੋ ਜਾਂ ਦੋ ਤੋਂ ਵੱਧ ਕੰਡਕਟਰਸ ਨੂੰ ਅਰੇਂਜ ਕਰਕੇ ਕੈਪੈਸਿਟਰਸ ਬਣਾਏ ਜਾਂਦੇ ਹਨ। ਇਹਨਾਂ ਹਾਈ ਸਟੋਰੇਜ ਕੈਪੈਸਿਟਰਸ ਬਾਰੇ ਅਸੀਂ ਅਗਲੀਆਂ ਕਲਾਸਾਂ ਵਿੱਚ ਪੜਾਂਗੇ। Let us now summarize what we have learned so far. Metals have less than half filled valence shells and therefore have a large number of free electrons available. This is why metals are good conductors of electricity. Only electrons are mobile in solid conductors, while in electrolytic conductors, both the negative and positive charge carriers move randomly and the net charge on the conductor is 0. Insulators do not have a significant number of free electrons and hence do not conduct electricity. When a conductor is placed in an electrostatic field, the electrons in it rearrange themselves by moving towards the opposite polarity of the electrostatic field. The redistribution of the charges at the surface of the conductor cancels the applied field and the net field inside the conductor becomes zero. Outside the surface of the conductor, the electric field is perpendicular to its surface. A capacitor is an electrical or electronic device that can store energy in the electric field between a pair of conductors separated by an insulator. These conductors are called as plates of the capacitor. The capacitance of a conductor is the ratio of the electric charge on it to its electric potential due to that charge. The SI unit of capacitance is farad. Practically, capacitance of conductors is expressed in submultiples of farads. Commonly used submultiples are a microfarad and a picofarad. Numerically, the capacitance of a capacitor is calculated as a ratio of the charge on the conductor to the potential difference applied to it. The capacity of an isolated spherical conductor is given by C equal to 4 pi epsilon naught into R. The capacity of earth as an isolated capacitor is equal to 711 microfarads. I hope that the concept of capacitors and capacitance is well absorbed by all of you. Let us now quickly test your understanding and the new knowledge from this class. I'll ask some simple questions that may strengthen the memorizing of basics of capacitors. The first question is, which type of charge carriers are mobile in electrolytic conductors, negative or positive? The answer is both negative and positive. The next question is, define a capacitor. The answer is, a capacitor is an electrical or electronic device that can store energy in the electric field between a pair of conductors. The next question is, define the capacitance of a conductor. The answer is, the capacitance of a conductor can be defined as the ratio of the electric charge on it to its electric potential due to that charge. Another question, why do we need to use submultiples of a farad to denote the capacitance of a capacitor? The answer is, practically the capacitance of conductors are small and a farad is too big a unit to express it. Yet another question, what is a picofarad? The answer is, a picofarad is a practical unit used to express the amount of capacitance of a conductor. It is equal to 10 raised to the power minus 12 farads. And now I am leaving you with a numerical problem which I want you to try solving yourself. A capacitor of 1.5 picofarad is connected across a 12-volt battery. Calculate the charge on it. Well, to cross-check your solution, let me give you the answer. Charge Q is equal to 1.5 into 10 raised to the power minus 12 into 12, which on calculating comes out to be 1.8 into 10 raised to the power minus 11 coulombs. ਹੁਣ ਅਸੀਂ ਅੱਜ ਦੇ ਪਾਠ ਦੇ ਅੰਤ ਤੇ ਪਹੁੰਚ ਗਏ ਹਾਂ। ਆਸ ਹੈ ਕਿ ਤੁਸੀਂ ਸਾਰੇ ਕੈਪੈਸਿਟਰਸ ਅਤੇ ਕੈਪੈਸਿਟੈਂਸ ਦੇ ਇਸ ਪਾਠ ਨੂੰ ਬਹੁਤ ਚੰਗੀ ਤਰ੍ਹਾਂ ਸਮਝ ਕੇ ਇਸ ਦਾ ਪੂਰਾ ਲਾਭ ਉਠਾਇਆ ਹੈ। ਇਹੀ ਕਨਸੈਪਟ ਆਉਣ ਵਾਲੀ ਇਲੈਕਟ੍ਰੋਸਟੈਟਿਕਸ ਅਤੇ ਇਲੈਕਟ੍ਰਿਸਿਟੀ ਦੀ ਸਟੱਡੀ ਦਾ ਆਧਾਰ ਬਣਨਾ ਹੈ। ਉਮੀਦ ਰੱਖਦੀ ਹਾਂ ਕਿ ਇਹ ਪਾਠ ਤੁਹਾਨੂੰ ਰੋਚਕ ਵੀ ਲੱਗਿਆ ਹੋਵੇਗਾ। ਪਾਠ ਤੇ ਧਿਆਨ ਦੇਣ ਲਈ ਸਾਰਿਆਂ ਦਾ ਧੰਨਵਾਦ। ਅਗਲੀ ਕਲਾਸ ਵਿੱਚ ਫਿਰ ਮਿਲਾਂਗੇ। ਤਦ ਤੱਕ ਲਈ ਗੁੱਡ ਬਾਏ ਐਂਡ ਆਲ ਦ ਬੈਸਟ।